reactions involving acid bases. So the first one is going to be a single replacement reaction. So here we go. Single replacement reactions, when we first learn these, it is an element that reacts with a compound, and then it forms a new different element is now free in its pure state, and a different compound has been formed. So we're going to apply this single replacement reaction specifically to acids bases. So in the single replacement that involves an acid is that our free element is a metal, and this pure metal reacts with an acid. So that's our compound. So this is our element, and this is our compound. And if this metal is able to react with the acid, the new free element is always going to be hydrogen gas. So that's our new free element. And then we have some sort of salt will be our new compound. So hydrogen gas will be our new free element, and the salt, metal plus nonmetal, will be our new compound. So this is our metal plus nonmetal. Now, we have to utilize our table J. The metal, okay, must be more active than hydrogen. So the metal must be more active or on table J, higher than H, because that's the component or the partner in the acid it's trying to replace. So when we take a look at this, okay, so we have K, this is our free element, potassium. It wants to come in and it wants to be able to kick H out. So when you look at table J, K is more active or higher on the table than H, so this reaction actually happens. So we end up with hydrogen gas, and we have our new salt, potassium chloride, KCl, and it's in solution, right? Because acids are in solution. It's not naturally balanced because we only have one H on the left and two on the right, so let's balance it. So if we put a 2 here in front of the HCl, we now have correct number of H's, but makes 2 Cl's on the left, so we put a 2 in front of the KCl. Now we have the same number of chlorines, but it makes us have 2 potassium, so we'll come back here and put a 2 there. Next example. So in this next example, lithium, the free metal, it wants to come and kick out hydrogen out of the acid. So when we go to the table, we have to compare where is Li in comparison to hydrogen. Well, lithium is above hydrogen in the list, so it's more active. The reaction happens. So we know right away the new free element is hydrogen gas. It's a diatomic, so it's H2. Lithium then forms a salt with phosphate, but lithium uses a +1 and phosphate uses a -3, so it's not a 1-to-1 ratio, so you have to get that formula correct. So it's Li3PO4, and this salt remains dissolved in solution. So once again, we see that it is not naturally balanced, so we need to do that. I notice hydrogen has a 3 on one side and a 2 on the other, so I'm going to use a common multiple. So in front of the H2, I'm going to put a 3, so that makes 6. And in front of the phosphate, I'm going to put a 2, so that makes 6. But that tells me there are 2 units of PO4. And over here, there's only 1, so I have to put a 2 in front of that. So now I have 2 units of the PO4, but it makes my lithium count 6. So I got to come over here and put a 6 in front of the Li. So now it's balanced. Last example. So copper being the free metal, it wants to come in and replace hydrogen out of the acid. When we take a look on table J and compare the relative activities copper to hydrogen, we notice that copper is lower on the list, so copper is actually less active than hydrogen. It's not able to replace it. So in this case, we simply write no reaction.